So this is the video for section 4.3, which is on absolute value. Remember, at any time you can pause or go back. This is how you're going to be learning this stuff, so make sure you understand what's in this video. The definition here is the absolute value is the distance a number is from 0 on a number line. So if I take a look at this first example, A right here, the absolute value of -6, if we plot those on a number line, the distance between 0 and 6, this distance here, is 6 units. Most of you guys know that absolute value just makes the number positive, but this is the actual definition. The absolute value of 5, if we look at it similarly, from 0 to 5, the distance is still 5. So if you forget it's always supposed to be positive, you can think you can never have a negative distance. So we know that these answers all need to be positive. The first thing we're going to do with absolute value is simplify. One thing to keep in mind is you want to treat the absolute value bars like parentheses. So simplify anything inside those first if you can, then we'll evaluate and simplify further. So in this first example, we have the absolute value of -6 plus the absolute value of 2. There's nothing we can simplify first, so we can go straight to evaluating. The absolute value of -6 is 6, and then the absolute value of 2 is 2. So we end up with a final answer of 8. In number 2, we have a couple places inside the absolute value bars that we can simplify first. So what we want to do here is say this is 4, and then 1 minus 4 is -3, so it becomes 4 times the absolute value of -3 minus the absolute value of -2. Now we can evaluate the absolute value, so we get 4, the absolute value of -3 is 3, and the absolute value of -2 is 2. And then following our order of operations, this turns into 12 minus 2, and we get an answer of 10. For part 2, solving absolute value equations, there are two ways we can think about this, one graphically on the number line and the other algebraically. We said the absolute value is the distance from 0. So to solve this problem, it says the absolute value of x equals 3. So it wants to know what numbers are 3 away from 0 on the number line. So if we go 3 to the right, we know that number is 3, and if we go 3 to the left, we get -3. So that's a way you can think about it graphically. Algebraically, what we want to say is, what can this x be that will produce a 3? Well, we know that the absolute value of 3 is 3. We also know the absolute value of -3 is 3. So what we can do here is take this x and set it equal to both of those values. So if x equals 3, the absolute value is going to equal 3, and same for x equals -3. That's a pretty straightforward example. We'll look at some more complicated ones in the next couple slides, but that's a good one to get us started. For solving more complicated absolute value equations, like we see here, number 1 and 2, the strategy we want to employ is to isolate the absolute value first, or get it by itself. So that's something you definitely want to write down in your notes. So isolating the absolute value to get it by itself in number 1 means we need to add 5 to both sides. So we have the absolute value of x plus 1 equals 8. Now the question we're asking ourselves are, what numbers could go in here that when you took the absolute value of them you would get 8? And at this point I usually split this equation into 2, and I say, well, x plus 1 could be 8, and that would give us an absolute value of 8, but x plus 1 could also give us -8, because that would give us an absolute value of 8. And then when we solve those, when I subtract 1 from both sides here, I get x equals 7. So there's one of our answers. And when I subtract 1 from both sides here, I'm going to get x equals -9. So we have two answers to that problem, as we'll have for a lot of these. We'll look at a couple special cases on the next slide, but let's take a look at number 2. So number 2, again, I want to get the absolute value by itself. So I need to subtract 4 from both sides first. That gives us 2, and then x minus 2 equals 6. Then I need to divide by 2. Again, we need to get the absolute value by itself before we do anything else. Now as I split this, I know that x minus 2, it could equal 3. That would give us an absolute value of 3, but it could also equal -3. And when I solve those out and add 2 to both sides, I get x equals 5, or x equals -1. So both of these examples had two answers, which we'll see a lot of the time. So we said a lot of the time we'll have two answers to these. Here's a couple cases where we won't. If here I add 4 to both sides, I'm going to see that the absolute value of x plus 1 equals 0. If we think about our definition on the number line, there's only one number that's 0 units from 0, and that's 0. So we won't be able to split this equation. So all you have to solve is x plus 1 equals 0, and we get x equals negative 1. In number 6, the first thing I need to do is divide by 3. When I do that, I get the absolute value of x plus 1 equals negative 4. Now this needs to be a red flag for you, because if we look on the number line again, distance we know has to be positive, so there are no numbers that are negative 4 units from 0, because the distance has to be positive. So this one's going to have no solution. So two things you're watching out for. If the absolute value equals 0, you'll only end up with one solution. And if the absolute value equals a negative number, we're going to end up with no solution. This last slide here is a nice summary. It goes over your definition one last time. The distance a number is from 0. What happens algebraically and to the actual number. It's going to turn the value of the expression positive. And then the number of solutions is a nice chart down here you might want to put in your notes. If the absolute value equals a positive number, we'll be able to split those equations and get 2 solutions. And then we see here the 2 special cases where if the absolute value equaled a negative number, we'll have no solution because distance can't be negative. And if the absolute value equals 0, then we'll have only one solution. So this wraps up this video. You're going to have some homework or classwork to do that would have been your homework had we not done a video. So we'll be doing that in class tomorrow. You'll be able to work with your classmates and ask me questions if you have any.